Well, hello, fellow Boilermakers. Welcome to CS177's online recitation video version. My name is Adnan. I'm going to introduce myself in a bit more detail in just a little bit, but welcome to the class, and let's begin. So, once again, welcome to the first recitation class online, or the video clip version of it. Um, so let's move ahead and introduce what what a recitation is, and what your expectations should be, what our expectations are, given like everything is a little different this time around. So the basic purpose of a recitation is to review some things that you already have done in the previous week. So we will mostly talk about some of the labs, some of the programming assignments, some good practices, some tips, and in some cases, including today, a bit into the future, meaning what's coming up. So this is actually the slide that you're seeing right now is the actual the physical version of it. So this is scheduled time. This is recommended but not required. But a video covering similar material will be available on Brightspace. So this is that. All right. Okay. So let me introduce myself properly this time. My name is Adnan Firoz. I am a second year PhD student. I'm one of your graduate TAs, and my office hours and everyone's office hours are online as of right now. So we will be live at those hours, but that doesn't necessarily mean that we will be online only then. Even if you have a question in the middle of the night, you want to post something, just do that. Someone will see it. We will try to get back to you as soon as possible. Okay, and feel free to reach out to me by email if you want to share your code or want to talk about some things that are going around, or like you're having any problem with the course and so forth. So today it's gonna be pretty simple and short because we're just starting the semester. I understand that things might be a little bumpy at the beginning, but things get smoothened out as we go along. Uh, and this might get a little challenging, but at the same time, this is extremely rewarding. Anyway, um, so, today's agenda is to look at program exercise 1-1, lab 1-1, and the questions and follow-up unfortunately has to go off to Piazza because we are not actually live. So, and besides this, I will also introduce Milestone 1 for the semester-long project. Okay, so let's begin. I will start with the lab portion, the beginning, because if you look at the content, then it makes sense to look at this first, because this talks about how to first fire up idle the development environment you are using by now, I hope, to write your Python code, and your future programs are expected to be written here, but there are other options. But for this class, we will stick to idle. So let's look at the handout. So this is lab assignment 1-1. This is an extremely basic introduction to how you should be running Python. So if you've read the getting started part of the course material, you already know about this, that you should install Python. And once you install the latest version of Python, idle gets installed by default. So you don't have to do anything extra for that. However, I understand that some of you are using a Windows computer and some of you are using a Mac. For instance, I'm using a Mac, and so there are some subtle differences on how to start this. So I'll take just a moment to walk through those two differences because I have both of the things installed on my machine. And first, let's look at Windows because the screenshot you see on the handout is from a Windows machine. So this is a Windows computer, or let's imagine this is a Windows computer, and you've just installed Python, the latest version here. And so if you go to your start menu, click on it, then you see that there's idle. It says idle, Python, 64-bit, and so on and so forth. But if you don't see that, then what you can do is you click on the start menu and then you just type in idle. So I'm just gonna type idle, IDLE, and there it is. Click on it, and there you go. And we're golden, all right? Okay. So that was the Windows bit of it, but I use a Mac, so I'll resort to the Mac. So if you're using a Mac computer, then what you do is you go to the terminal, and in your terminal, once you go to your terminal, you type in idle, IDLE, hit enter. Now be careful with something here. If you have not installed Python as the latest Python version as your default Python language version, then once you fire this up, what you will see is over here at the very top, it says Python 2.7 point something. So it's 2.7 basically. So this is not what we are looking for. So if you are using a Mac computer and you are seeing this, this is not it. We don't want to use this. So what you do is we close this, and then we type in idle 3. Here's the thing, chances are if you just do idle, it's just gonna work. It's not gonna be 2.7, it's gonna be 3.8. In that case, you're good, but if you see that you are getting 2.7 something in just the idle command, then type in idle 3. Hit enter. Now look at the difference here. It's Python 3.8.5. So this is what we are looking for. So this is the latest Python version, and we want to stick to this. Now let's go back to the lab assignment, and what we see here when we fire up idle is what we call the idle shell. So this is where we can do our like scratch work, experiments, and things like that. However, we will write our full programs not here, but in an actual Python file. So think of this as a sandbox or a playground for Python. So there are some examples given here that we can try. So we can just try that. We can do, it said 5 plus 2. Let's do 4 plus 3 and hit enter. You see that's 7. Okay. All right. So now let's do some variable assignments. So let's assume x is a variable and we want to print that. But notice that we have not assigned anything to x, so this should not work out. So if we hit enter, you see that we have a problem. So now we should give x some value. So let's give x a value. Let's assign the number 10 to x. Now x has become 10. Now if we print out, if we write print parenthesis start, x parenthesis close, hit enter, see 10. Okay, good. Now, another thing that sometimes confuses students is something like at the increment of the same variable, something like x equals x plus 1 is something that you should bear in mind is once when you write x equals x plus 1, or if I zoom in here, it will be easier to explain that if we do something like that, then this does not mean that x is the same as x plus 1. So that equal sign does not stand for equality. In programming, not only in Python, but in most popular languages, the equal sign stands for assignment. Assignment and equality are not the same thing. Assignment means do some operation on the right, take that value, take that result, and assign this value to whatever we have on the left hand side of the equal sign or the assignment sign here. So what we want expect here to happen is we want to have the value of x, add 1 to x, making it 11 at this point, and then assign that value back to x. So if we do that, and then if we print x, then we see that the value of x has become 11. So this is actually covered in great detail in the book. So you should always refer to the textbook whenever in doubt. And we are always here also. Okay, so moving on from that, let's look at the simplest looping structure that we have encountered till now. So over here, there's a code snippet for n in range 3. Let's print hello world. So let's just go ahead and do that. So let's do for n in range 3. Observe, this is important. There's a colon here. So there's a colon here. So this kind of syntactic nuances are important, or else there will be syntax errors. Hit enter. You see that the cursor has moved a little bit on the right. So this is called indentation. So this indentation means whatever I'm going to write now, it's going to be counted inside the loop. So this is going to loop 3 times. So we'll do print hello world. I understand I kept everything lowercase, but that's fine for now. Let's go back, hit enter, and there we have it. So we're printing hello world. Okay, 3 times. So what if we wanted to do this? How about 50 times, like for n in range, or like 50 to print hello. Let's just stick to hello. Hit enter, go back. I just hit a backspace to tell the interpreter that I'm done writing the loop. Hit enter, and it's gonna just print hello 50 times. So this is kind of the power of programming. You don't have to actually write this 50 times. Instead, the loop is going to take care of it, right? Okay. So this was pretty much an introduction to the Python's idle shell. So this is where you can play around with variables, loops, and so on and so forth. You can also do this. You can save this whole thing, like to file, save as, and go ahead and save it whichever way you want. But now let's actually write a Python file, a Python program that is which is the lab1.py, and it's actually given to you. And the thing is, I don't want to, like, take too much of your time typing this in front of you. So I actually have this typed up. I'm just gonna go and open this. So there, there it is. Now notice that there are some lines at the top of the program that have the pound sign, but more popularly known as the hashtag these days, thanks to Twitter and all that, social media. So every time you put a hashtag or a pound sign in front of a line in Python, that means that it's a comment. So Python will not consider those as part of your program or at least executable program, but that's for describing what you are doing. So even though they don't execute, these are extremely useful for you to guide yourself through a program when you're writing longer programs, and also for us to understand or for other people to understand your code. So it's very, very highly encouraged for you guys to comment your code well in a descriptive manner. Okay. So now that we have followed all the instructions, we have copied everything from the handout, we have pasted the whole thing, typed it up. Let's run this. We go to run. Okay, just before doing that, I want to point something else out as a good practice. A good practice is to, when you are writing a program in Python in idle, it's always good to have your line numbers being shown. So it says, in the options menu, let's show line numbers. So this actually helps you to address things when you're talking to a different person like us. You can say that, okay, I have a problem in line number, let's say 22 here. So it's always good practice to have line numbers. So now that we have everything here, let's go to run module. And what happens is, uh-oh. Oh, it was just being slow. I'm sorry about that. Okay. Okay, so as expected, it's asking for my name. So let me put in my name. My name is Adnan. Hit enter. What's my current age? Let's assume I'm 7 years old. Hit enter. Well, happy birthday to me. I have lived at least 2,556 days already. It should be quite trivial for you to figure out the logic in this program, how that number was calculated, which is in line 22 here. And in line 14, we take input. So please read the corresponding section of the textbook for about taking inputs. I'm sure you've had plenty of practice by now on taking inputs by looking at most of your submissions. Okay, moving on from lab assignment 1. Let's close this. Now let's look at programming exercise 1. So over here, the first instruction was to look at section 1.6 of your textbook. And I hope you have done that. Good job. Then let's start idle by doing file new and start a new editor. Just for demo purposes, let's do that. File new file, and there you go. You can like, okay, another program, print hello. And this would be a program, not a good program, but this is a program nonetheless. Anyway, okay. So we'll start the idle program and we are going to write this verbatim. Writing this verbatim is important because of the indentation. Because if you don't indent them properly, they won't work right. So now that we have the chaos.py file written out in advance, let's just first give it a whirl. Let's run it. Okay, let's do run module. Ask for a number between 0 and 1. We'll do 0.25, like in the handout. And we see that we get 10 numbers following this equation here. And the reason we get 10 numbers is because we are looping through this for 10 times. It's 10 here as an argument inside the range function. So what if, just for an experiment, we want to print 4 numbers. Let's change the 10 to 4. Save it. Run it again. Let's do 0.25 again. You see, we have only 4 numbers. Now, the main thing to do for this specific assignment is that, whoops, I made the wrong file. Okay. Is the number 6 part. We have already gone through 1 through 5. So let's focus on number 6. It says modify the chaos.py program so that the number of values displayed is determined by the user. So there's a sample output given here. If we compare this to the one in the back that we just ran, we see that there's one extra line. This is how many numbers should I print? So this number should be given by the user. And you can see here that we know how to take user input. So because we are already taking user input and assigning it to this variable called x. So for similarly, let's take another variable y, do the same thing, do an eval, meaning whatever input I'll take will become a number. Input, and let's put in the actual comment, prompt. And the prompt would be, how many numbers should I print? So let's write, how many numbers should I print? Now here's the thing. We have written a line to take this input and assigned the input to y. Let's save it. Let's run it. Again, enter a number between 0 and 1, 0.25, hit enter. How many numbers should I print? Let's say we want to print 20 numbers. Uh-oh, something is wrong. We just printed 4 numbers just like before. So we are not done yet. And why did we just print 4 numbers? Because over here, you see that we never changed the range of the loop. So the number of iterations the loop will run, which is still 4. But we don't want it to run for 4 times. We want it to run for the number of times the user has inputted. So we want that not to be a constant number, but a variable, which is y in our case, because that's where we are storing that value. So we just change that to y. So to file, save it, run module. Let's do 0.25 once again. How many numbers should I print? Let's try 20 numbers. And ta-da, we have 20 numbers. And that's what all we're expecting from this exercise. So we are done for programming exercise 1. Now, those were the major parts of last week. But now, going forward, there's one assignment that you will see on Brightspace under Assignments tab, which is called Milestone 1. So I want to talk a little bit about that, and mostly I'm gonna introduce it to you, not go too much in detail, because we will be building up on this in the next few days. So this is basically the first part of the semester-long project that you will be doing. And this is basically a fun trivia game, which will include graphics and all sorts of fancy fun things. But this is the very first small part of the big whole. Okay? And for this specific milestone, or this specific sub part of the game, what you are going to make is called what we are calling the quiz generator. So in this part, it's simpler to go by parts. That way it will be more obvious to you guys what you are supposed to do here. So we will create a Python program named milestone1.py that includes the header, just like the ones you submitted already, your name and things, and all commands should be in the main function definition. This is important because from now on we will always write things inside in one or other function. For instance, in this program, all the main codes were in a function called main. This is where we defined main, then we wrote the whole main function, and this is where we called that. Okay, this makes me anxious, so let me just go and show line numbers. Okay, now coming back to this. Now, initially, what it's supposed to show on the screen is something that looks like this in the box. It says quiz creator. Now, the quiz creator, you should focus on the formatting here in detail because it has been described in pretty well granular details here. So quiz create, it should say the text quiz creator at the top, which should be center aligned, and there should be a double line border that should be centered within 50 characters. So it should look exactly like this. And the way to get this working or to make it look like this is for you to use the dot format method. So to learn more about the dot format or formatting strings and most of the content of the Milestone 1 portion of the project is being covered in chapter 5 of your textbook. So I strongly recommend you read that and start early. Okay. So this is the displaying description of the program. Observe that this is not simply printing things out. You are formatting it just like the way it is shown here. Okay, now moving to part 3. In part 3, what you do is you ask the user for two things. First, you ask the user for the title of the quiz. You can call it whatever name you want to give that quiz. You can call it Quizlemania or Purdue Quiz or Boiler Up. However, whatever input the user gives, for instance, in this example, the user has inputted the quiz name as example quiz. So example space quiz, all in lowercase. However, what your program needs to do is to make the first letters of each of these words uppercase. So boiler up, all lowercase, should be stored as boiler up with the B capitalized and U capitalized. Similar with this example with Purdue University. And then there should be a second question that you get asked the user, where the user needs to input how many questions there should be in this quiz. Now, observe that in this question here that is phrased, it says how many questions in the example quiz. This example quiz term is not hard-coded. These two words are coming from the input given in the first input from the user. And look at the E and the Q. They have been uppercased. Okay. So now user inputs that I'm gonna input 2 questions. So now what we do is we need to create a list of quiz questions. Whoops. Now we in chapter 5 or this week, or depending on when you're actually watching this, we might have or might not have covered lists, but there's a good chance you will be introduced to lists by the time you watch this. So a list is a data structure, as we call in computer science, but think of it as a collection of things. So in a list, in this list, the way we are going to store the question string is in this form, which is the question text, meaning, and there will be examples below, comma, answer A, comma, answer B, comma, answer C, and the correct answer, the correct choice. So think of yourself as a grade school teacher creating a test for your students, which they are going to take. So you're the teacher here. So you are not actually taking the quiz, you are making the quiz, at least in this specific milestone. And now once you have made a bunch of these things, we will move on to the next part. But before that, let's look at an example. So if the user had inputted, like before, that there are going to be 2 questions, we will look through them and ask him twice in the form that enter question number 1, and then the user types in what color is the sky, and then it asks for answer A. You give him a choice or her a choice, red, and then for B, another, the user inputs blue. Then for C, user inputs user inputs green. Then the program asks which is the correct answer, A, B, or C. So user inputs B. Observe that the user has inputted B in lowercase. But now when you store this question in your program, the way it should be stored is what is the color in the sky? That's the first bit, comma, the first choice, comma, the second choice, comma, the third choice, comma, in uppercase, the correct choice, which is B in this specific one. So this is a string. Now, about the thing that I was talking about, which is a list a minute ago, is a collection of these questions. So let's say we had 2 of these question strings. Then we would have a list of strings that contains 2 strings in this example. However, in your program, it can be arbitrarily wrong depending on what the user inputted here. Instead of 2, if it was like 5, then there would be 5 strings at this point. So the first question is, what's the color of the sky? Red, blue, green, or B? The second question being, what is the meaning of of life, the universe, and everything? Is it love, pizza, or 42? It's 40. Yeah, the answer that has been said is 42. It's a fun reference to Hitchhiker's Guide to the Galaxy. Uh, well, it's a cool reference. Maybe you should look at it. But that's not part of the class. Don't worry about it. Okay. And then, as the last bit, you want to display the formatted quiz. And there is a sample output shown here that once you have taken inputs and stored them like the way it has been described here, it should show up just like this. Like, what is the color? In the top, it should say the title of the quiz. It could be any name that has been given by the user with the first letters capitalized. Then the question 1, there's a space there. What color is the sky? The 3 choices. What's the meaning of life, the universe, and everything? 3 choices. Then answer key for quiz. And the name of the quiz. Then the choices. Now, here's the thing. Just printing this out is not good enough because, again, I can't stress this enough, that you need to focus on the formatting, because we have given you every specification, such as the name of the quiz and the double line border of the same length should be centered within 50 characters, and such and so forth, and all elements should appear just the way it looks in the sample output. So again, this is just a recap of what you need to do. Then there's the rubric, and I cannot stress enough to say that you should start early on this. Don't get overwhelmed. We are going to work with you, and we have office hours, and we are online. You can reach out to us almost all the time. So feel free to reach out and don't get overwhelmed. This is really, really rewarding. All right. So have a great week. Thank you. Thank you so much. See you again soon. Bye.